Welcome to this session. In this session, we are going to see another two applications, SVG and one more application. In the SVG Scalable Vector Graphics, it provides an opportunity to store images in vector format. It means, so images can be represented generally in two-dimensional array, so that vector graphics format is used for storing two-dimensional graphics. So SVG is an XML based vector image format as like CDF. See, common data format used to store textual representation. Previous session we have discussed about CDF. So it is used for storing textual representation, but SVG is an XML based vector image format for two-dimensional graphics, for 2D graphics. See, in the 3D image representation itself is complex one. Other XML applications used for storing 3D images, 3D graphics, but here SVG used to store the images or graphics in two-dimensional array. And then it provides support for interactivity as well as animation. So by using graphics, we are able to do animation, and at any time or any frame, we can interact with the frame or we can give some input to the frame. That is also possible. So it provides support for interactivity and animation. And this specification is an open standard and developed by W3C, World Wide Web Consortium, from 1999, right? It is developed and released in 1999. So SVG specifications is available, is an open standard, open access. SVG is used to define vector graphics format. Any images or any graphics if you are giving, that will be represented and defined in SVG. Defined in SVG format and stored in an XML text file. Stored in an XML text file. So if graphics or images represented in XML text file using SVG. It provides APIs and other format for storing images or graphics in SVG as well as XML text file. See, what is the benefit of storing SVG? I mean, storing images in SVG format. It can be scaled. It can be scaled in size without loss of quality. That is very important. See, you just paste a small image in picture or a small image or picture in Paint and you expand the image. Automatically, it lost the quality. The resolution has been changed. The image quality changed, or it lost its resolution quality. But it is not happening in SVG images. We can scale or we can expand in size without loss of quality. That is very important. As well as if you want to search a file, that is possible through SVG. And indexed, scripted and compressed. See, if you are storing a larger graphics, definitely the size is larger. It is not easily ported from one location to another location. In such case, it provides compressing technique also, right? You can compress your data and transfer the data to some other locations. So compressed, scripted, we are able to do scripting process. The images can be retrieved and stored using scripting languages and indexed. Not only scripting languages, scripted by means of all programming languages. By means of programming languages, we are able to communicate with the SVG files. As well as compression is possible. We can search the SVG file and index the SVG file. And then the XML text file is created after the SVG file. After the SVG file, XML text file is created and XML file is edited by using any text editor. Any text editor, we are able to edit the XML text file, or you can make use of vector graphics editors where you can edit the XML text file. And also the XML text file are rendered by most of the browsers, And then we'll see the overview about SVG. As I said previously, it is released by W3 Consortium since 1999. It allows three types of graphical objects. Vector, graphics, shapes, straight lines and curves, right? Obviously, vector graphics shapes are made up of straight lines and curves. Such kind of images can be represented using SVG, and then bitmap images and textual information also represented by SVG. Bitmap images, BMP, bitmap images also represented using SVG. And then the SVG drawings, as I said previously, straight line curves, that kind of drawings can be interactive. You can include animation, as I said previously. And then it is defined in the SVG XML elements or scripting that can be accessed. As I said previously, by using programming languages, we are able to interact with our drawings, and if possible, you can include animation into your graphics through scripting languages or through scripts. It is possible. And SVG document object model, DOM, is also used for accessing the content. SVG uses CSS styling. See, most of the graphical rendering languages or graphical rendering formats uses CSS1, CSS format 2, format 3 and so on, because CSS mostly supported by all browsers. That's why all such representation uses CSS for styling, and JavaScripting for scripting. As I said previously, you can make use of scripting languages and other languages to communicate with the SVG images. So JavaScript support, inbuilt support provided for JavaScript by SVG. And then text representation. See, when you are representing text, means you should consider internationalization and localization, right? See, I'll tell you one example for this. Whenever the customer viewing the web page from India, say for example, the web page contains product information and the price details of the product. You want to display based on the customer location. You want to display the price. Suppose the US customer viewing the content, then the price should be displayed in dollar, in terms of dollar. That conversion automatically made, and it should be approximate dollar conversion you can present in the web page. Suppose the user viewing the content from India, then the price should be displayed in Indian rupee. As well as suppose the time information, date and time information is displayed in the web page. Based on the location, you can change the time format, date format and so on. That is called as internationalization and localization. So when we are providing support for text, we should concentrate on this internationalization and localization, right? We need to concentrate on these things. So SVG already provides support for internationalization and localization. You can customize the content based on the locations, based on the country, state and so on. And the next one, SVG images contain many repeated fragments of text. Because same kind of informations may be available in the graphics in several locations, so that repeated fragments of text may be available. What is the benefit of that kind of repeated fragments? In such case, it is well suited for lossless compression algorithms, lossless compression techniques or algorithms. We are easily able to apply lossless data compression algorithms into SVG images, because SVG images contains repeated fragments of text. That is the another benefit of SVG. And the SVG 1.1 specification defines 4 functional areas or feature sets: paths, basic shapes, text, painting, color, and then gradients and patterns, clipping, masking, compositing, and filter effects, interactivity, linking, scripting, animation, fonts, and metadata. There are 4 major areas specifications available in 1.1. Functional areas are feature set, right? Features of SVG. Paths. See, we can define the path in straight line or curved line. So simple shapes can be drawn using curved line, straight line, as well as compound shapes can be drawn, as well as you can fill the shapes, and you can clip. If it is exceed or lot of clippings algorithms available, you can make use of all those things. Clipping path, a particular route or path can be clipped or extracted using this technique, clipping path. If we can fill any pattern or outlined, also supported by the SVG specification. So path related features present in SVG 1.1. And then basic shapes. The basic shapes like rectangle, triangle, circle, ellipse, square, and polygons, all those basic shapes can be drawn and represented and stored in SVG. It provides that support. And text, Unicode character text is available in SVG file, right? Unicode character text support is available in SVG file, so that we are able to express XML character data using SVG. And then SVG shapes can be filled and outlined. Already I told that in order to fill the shapes or outline the shapes, it provides a painting facility. Painting with color and gradient and so on. Using SVG, we are able to do the painting process. Through painting process, we are able to fill the shapes and outline the shapes. And color can also be applied to the SVG elements, either directly or via fill, stroke like methods available. Fill, stroke properties available. Through that property, we are able to apply the specific style, or directly you can include, right? Or directly you can include the color related aspects into the SVG elements. And then gradients and patterns can also be applied. That may be linear or circular. We can apply the gradients. That effect we are getting, linear straight line effect we are getting in the gradient. Circular, either focus in or focus out, circular effect we will be getting in the SVG elements or SVG images. Gradient effects we are able to get. And then clipping, we are able to clip a particular portion of the SVG images or text. Those informations can be clipped. Either inside region shapes can be clipped, or outside region shape can be clipped, or you can mask a particular portion of the images. Or you can change a particular portion of the images in different color or different gradient and patterns. If you want, you can change. That API is also supported in this specification. It is available in the specification, supported by SVG 1.1. And then filter effect. Filter effect consists of all information regarding the graphics is not necessary for searching or for further processing. Then you can apply the filtering effects. You can modify the result, and that will be used for further processing. And interactivity, SVG images can be interacted. It is interacted by the user. Any part of the image as a whole, right? any part of the image, SVG image, or whole image can be interactive, as well as we can you can click the image, and whenever you are clicking the image, you want to do certain task, then event related activity can also be included, right? Obviously, when we are using interactivity, event related programming included there, because whenever a component, SVG component, is getting the focus or lost the focus, you are expanding the elements, resizing the elements, scrolling the window, and zooming in or zooming out the images, and keyboard, key press, key release, like keyboard events or document events, minimized, maximized, scrolled, horizontal scroll, vertical scroll, and so on. A lot of events are defined already in the net. All kinds of, not only net, all languages provides, all event oriented programming languages includes all those activities, all those events, so that all those wide variety events, we can say in that way, wide variety events can be supported, and SVG provides interactive nature for the users. If they want to do any task, or if the user wants to do any activity, they wanted to perform any functions, everything is possible because of this interactivity nature. And then you can link SVG images to other document, right? SVG images to other documents using Xlink. That provision is given by SVG specification 1.1. And then scripting, we are able to do scripting. It means we can include any dynamic nature into the text or into the SVG images or SVG document. So SVG document can be accessed and manipulated using scripts. Default scripting languages supported by SVG is JavaScript. And then animation. In some cases, if you want to attract the user, right? If you want to attract the user, then the user have to include animation into the SVG content. That animation, built-in animation support is given for SVG content or SVG element. In order to provide animation for the SVG content, it supports animate motion, animate color, like tag included in SVG. We can make use of all those tags for providing animated content to the user, and content can be animated by the manipulating DOM object. Already I told the document object model, a tree structure maintained here, right? A tree structure maintained where each and every node represents the elements. So such kind of DOM objects created and represented using ECMA script and scripting languages can be used for maintaining timers. Time-based or timer-based activities, if you want to do that, you can perform using the animated effect. So animation effect we can include into the SVG content, that built-in support provided by SVG 1.1 specification. Next one, fonts. See, SVG specification provides font support. It means, obviously, when we are displaying the content, we are able to display the content in any font. That is also be changed based on the events. When we are moving the cursor towards a particular text, the text is appeared in embossed format, or shrinked format, or expanded format. Likewise, or some star or like FX we can include in the font, and so on. When we are moving the cursor towards the text, we can split the text, or we can throw a star. Like FX, we are able to include font supports provided. As with HTML and CSS, SVG provides font support. Suppose the font is not available in that machine, still even the SVG file is rendered. But what is the case? What is it font used there? frequently that font, by using that font, it is rendered instead of the original font. So that generally this particular point we should remember when we are developing the content. During the content development phase, we should consider the font support provided by the browser in SVG representation. That you should remember, and accordingly you need to prepare it. And next one, metadata. See, metadata is very important aspect regarding the web document. If you are providing enough content in the metadata, then only you are able to fetch and use the content. So that in accord with the W3 Semantic Web Initiative, SVG allows authors to provide metadata about SVG content. It means very simple, very older content. When you take very older websites, nowadays mostly 99% of the websites have updated. But if you are having any content with the older websites, you see that very minimal metadata available because it is not a mandatory for initial stages during the 2000 and so on. But nowadays, when we are hosting any application, when we are storing any web document, metadata information is very, very important. That should be utilized by the search engine. that should be utilized by the search engine for providing better result during the searching process. So that SVG allows to include metadata for SVG content. Metadata tag is defined. Metadata tag is defined by the SVG, and then through that metadata we are able to give the information about the document, or we can describe the information about a particular elements or all elements available in the document and so on. Title, creator, what is the title of the document, who is creating the document, who is the author of the document, or what is the subject content it deals with, and description regarding the web page or web content and so on. All those things comes under metadata information. Metadata information. We will see one example for SVG file. See, in SVG, as usual, it starts from it starts with the XML. It starts with the XML, and then XML version equal to 1.0. XML version equal to 1.0. XML version equal to 1.0, and then encoding UTF-8 standard encoding format. Standalone, no, this is also already studied. And then doc type, public or system doc type can be given. Doc type SVG, it is a public content, so they are providing the DTD specification for all category, all applications, XML applications defined with their own DTD. W3C, it is available in the W3 consortium. So DTD SVG 1.1 ENG, that SVG name is svg11.dtd. It is available in this location. So doc type, which document is referred during the translation process or compilation process. And then all tags are starts with the SVG tags, right? SVG. And then width equal to, height equal to, view box, that portion, I mean, already we have discussed the box content in CSS, like view box is created. Within the box, we are able to display the content, and then XML namespace. As I said previously, in this program, they are filling the rectangle, they are creating the shapes They are creating the shapes rectangle. Fill equal to filled with the color. Stroke, we can provide some attribute x, y coordinates where we want to display the rectangle. At x, y coordinates, what is the width of the rectangle, height of the rectangle. Generally, in order to draw in the rectangle, there are 4 parameters needed. Starting point, right? Starting point, x, y coordinates, and then width, height. I mean, let us say I am starting the rectangle to draw the rectangle from this point. X coordinate in the window, right? In the window, x coordinate and y coordinate, and then width, right? Width, height, that will be completed. So this kind of information, 4 parameters are needed. All those parameters are supplied, and what is the color we need to fill, and any other pattern we want to display, that is respective designs can be included in the rect tag. It is defined by SVG. Rect tag is defined by SVG. And then G tag, we can give some graphical related properties, opacity, as well as we can group the controls: rect, circle, polyline, line. There are 4 objects drawn here. Rect, rect, circle, polyline, line. Based on the shapes, we can have different parameters. Based on the shapes, we can have different parameters. So circle, we need center and radius. Fill is orange. Polygon, number of lines or number of sides, we can give values. For each and every point, 2 values are needed. According to this, there are 4 sides are given. Polyline, line, only 2 points, starting point and ending point given, x1, y1, x2, y2 value given as a parameter, and then the other properties, if you want, you can include that. This is an example for SVG graphics script. Next one, GPS exchange format. As I said previously, GPS exchange format used to describe and represent the GPS data. So when we are seeing GPS data, track, route, points, this terminology is very familiar. What is it? We'll see later. GPS, as like SVG, it is also an open format, right? It is also an open format, license-free format. Any users can wants to use, they can download and use, open standard. And location data, obviously in GPS, we are finding the location data, or we are getting the location data. So that location data, elevation, time, and other informations are stored in the tag. For later retrieval. See, very good example. If you are setting alarm, let us say you are traveling in a train. You want to set from Trichy to Chennai. If you want to set, right? If you want to set timer when it crosses Chengalpattu. You want to enable the alarm. In this application, how it identifies the reachability of Chengalpattu? It means by using latitude, longitude values, it identifies that location, and other properties also included there. Important property, latitude, longitude. So by using all those informations, it identifies the location. Once the location is identified, immediately it enables the alarm application. Automatically will be getting the ring, right? So that kind of location data is stored in the XML and interchanged between the device and software, right? Obviously we need the locations by using GPS device, right? By using GPS device only, we are able to get the location. That locations exchange, that information exchanged between the software and GPS devices. See, if it is exchanged to the software, then only it enables the application, alarm application, so that GPS devices and software gets exchanged the information stored in the GPS format. GPX, right? GPX file is needed. As I said previously, waypoint, track, routes can be represented using the variable WPT type, RTE type, track, TRK type, RTE route type, track type, and then waypoints. WPT type is an individual waypoint because the data set contains a larger collection of points. WPT type refers independent collection of points. It consists of coordinates, as I said, latitude, longitude, like the coordinates of a point, possibly the other descriptive information is also included in the WPT type. And route type, ordered list of route point from one place to another place. You are in the traveling, you are riding a bike, let us say. I think you may not have enough information about the route. You don't have enough information regarding the route. In such case, you can start the map or route app. It says the route. How it says the route? There are several route points are available. Several route points are gathered by using the GPX data, and then all route points are connected. All route points are connected. It is an ordered list of route points, a series of route points, stage points that will be connected together. That will lead to a destination. That will lead to a destination that is called as RTE type. And then track type. Track made up of segments. Made up of segments. The segments comprises waypoints. Segments comprises waypoints. So ordered list of points describing the path. Ordered list of points describing the path. And then a track is made up of sufficient number of track points, already told in the previous slide. So precisely draw every bend path is very, very important. The other places, straight places, simply you can make use of smaller points, smaller track points. But bend definitely should use a track point. Definitely should use track points. The raw output, GPS data. For example, GPS recording of the course of one trip, or existing data. Already you have visited and you have created the data, then first case, and then rearrangement of such points, to remove the excess ones. See, sometimes unwanted points, track points may be collected and stored. That is not necessary. You can remove that unwanted points, track points. See, very closely the track points may be located. It is not necessary. If it is a straight line, very close track points can be deleted. And then data from any source, any vector map or any other source, we are able to get the tracking information. We are able to get the tracking information. Next one is a route. A route is made up of route points. Already I told that it collects based on the location information. It collects several route points, and all route points are connected together, and it creates a route and it guides you to follow the route. And then sometimes we may get direct information, direct location informations, or stored information from vector map. It may take stored information, already visited route and other informations already recorded, means we can take the value from the vector map. The route points may be crossing or junctions or distinct stopover towns. So obviously, when we cross several cities in the route, all towns and cities are important places noted, that will be taken for noting the route points. Sometimes you may see the route point, and instead of routing to the original destination, in between you may go to that place and you may take some cup of coffee and so on. Suppose the hotel information is available in the route, then immediately you can change your mind, go and take a cup of coffee, and then we can continue the traveling process. If you are thinking in such a way, in order to cope up with that idea, the track points are created. Track points are considered the town, and then hence such a project can be saved and reloaded in the GPX file. Obviously, I told you earlier, for the first time if you are visiting or first time you are collecting the data, then that must be stored in the GPX file. For later you can reload the GPX file. And then the process is called as routing, computing route. That process is called as routing. It takes existing point or new points from the location information and construct the route that will be used for traveling. The GPX points may contain the text of those instructions. And then this is the sample GPX document. As I said previously, all related document starts with GPX tag. Here that doc type information is missing. Where we can find GPX and the related DTD, related GTD. Here in this example, XST only given, GPX XST only given. In the doc type tag, we can supply either public or system. Generally, it may be the public, and then we can supply the DTD information and the XML NS, GPX, points, PX, and so on, creator, and version, all those informations are XST, XML namespaces related informations are included here, and then metadata. It includes the metadata. See here, metadata, a link href, garmin.com, textual representation regarding the link, and then time. These are all the metadata, link and time information stored here, and then track, TRK, right? Track, TRK. Track name is example GPX document. Track segment, track point, latitude, longitude, and then elevation 4.46, time, at what time this particular latitude, longitude taken, elevation is taken, that information also recorded, and then close the track point and another track point. Likewise, you can include any number of track points, track segments, and latitude, longitude information, and so on. These are all the GPX content available in GPX file. GPX file that will be utilized for your GPS processing. So GPS, important application of XML. So remaining applications we will see in the next discussion. Thanks for listening. Thank you.